video, page 867, numbers 75 through 81. Odd. Let's go ahead and get started with the homework. Here we go. There's the first problem. And let me get out a sheet of paper here. Just give me 1 second. I have these worked out ahead of time, written down. Okay, here we go. Okay, a furniture company can sell all the tables and chairs that it produces. So, if the company knows that it can sell all the tables and chairs that it makes, then they're going to make as many as they can. Now, each table requires 1 hour in the assembly center and 1 1/3 hours in the finishing center. So I'm going to put a table right here. In order to make a table, you have to have 1 hour in the assembling center, and you have to have 1 1/3 hours. I'm going to go and put 4/3, 1 1/3 hours in the finishing center. Okay, now let's continue on. Each chair requires 1 1/2 hours. I'm going to put 3/2 in the assembly center. And each chair requires 1 1/2 hours in the finishing center. So 1 1/2 is 3/2 in the finishing center. Alright. The company's assembly center is only available 12 hours a day. Its finishing center is only available 15 hours per day. Find and graph a system of inequalities describing all possible production levels. So are you ready, students? Here we go. Now, first of all, let's start with the assembly center, okay? We're going to use our unknowns are going to be T and C for obvious reasons. So every table gets multiplied by 1, because every table takes 1 hour in the assembly center, plus every chair takes 1 1/2 hours. So every chair gets multiplied by 3/2, and that must be less than or equal to 12 hours, because the assembly center is only available 12 hours per day. Does that make sense? Every table gets multiplied by 1 hour, because each table needs 1 hour in the assembly center. Each chair gets multiplied by 3/2, because each chair needs 3/2 hours in the assembly center. Now, I don't like this fraction here, so I'm going to go ahead and multiply. Well, we'll worry about that later, okay? But when we start graphing this, okay, there's one equation. Now, let's move on to the finishing center. Every table gets multiplied by 4/3. Every chair gets multiplied by 3/2. And all of that had better be less than or equal to 15 hours, because the finishing center is only open 15 hours a day. Now let's use our common sense constraints, or our common sense inequalities. There's no way you can make negative tables, so we know T has to be greater than or equal to 0. And we know there's no way you can make negative chairs, so your chairs must be greater than or equal to 0. So there you go, we did it. Step 1 is done, or part 1. Find the system of inequalities. Now we're going to graph this system, okay? So we no longer need this word problem. We no longer need that information. Let's get rid of this. And let's pull this up here. And let's graph this system. Now, my advice to you is to simplify each equation the best that you can. For example, I'm going to multiply everything by 2 to get rid of my fraction. So 2t plus 3c is less than or equal to 24. I multiplied everything by 2. Okay? Here, I want to multiply everything by 6, because I have a 3 here and a 2 here. So multiply everything by 6. You would have 8t plus 9c equals 90. Okay? 6 times 4/3 is 8. 6 times 3/2 is 9. 6 times 15 is 90. And then, of course, these here are totally fine. Let's put less than or equal to. There we go. So we'll go ahead and bring these over. Alright, so let's go ahead and graph the system. Now, hopefully you remember how to do this, okay? Let's start off with your first equation here, okay? We're going to use the double intercept method to graph this linear inequality. I hope you remember what that means, students, okay? We're going to put a 0 in for C. If we put a 0 in for C, T would equal 12. Then I'm going to put a 0 in for T. If I put a 0 in for T, C would equal 8. So my T-intercept is 12. and my c-intercept is 8. Let's review that for a second. Remember in algebra 2, if you're looking for the x-intercept, you put a 0 in for y. If you're looking for the y-intercept, you put a 0 in for x. Well, the same thing applies here. If you're looking for the t-intercept, put a 0 in for c. If you're looking for the c-intercept, put a 0 in for t. Okay, let's come down here and do the same thing, okay? If you put a 0 in for c, you're going to get out, let's see, 10, 11, 11 and 1/4, I believe. And if you put a 0 in for t, for c, you will get out 10. So now I've got some ideas of how big I need to draw my coordinate plane. My intercepts are 12, 8, 11 and 1/4, and 10. So I now can kind of figure how big to draw my coordinate plane. So here we go. Now, it doesn't really matter which axis you call T and C. I'm going to call this axis T and this axis C. If you flip-flop that, that's totally fine. So students, here we go for your t-axis. Let's go all the way up to 12. All the way up to 12. So here we go. Your c-axis has to go all the way up to 10. 10 is your biggest number. Okay, we're going to graph the first line here in black. So I'll circle it in black, okay? So the t-intercept is 12, and the c-intercept is 8. So there we go. There's our line, okay? There we go. Now students, actually, you're welcome. Students, it's okay if you want to draw the line through the axis all the way through like this. That's totally fine. Like that. Eventually, those are going to get cut off, and you'll see why in just a little bit here, okay? But anyways, there's the line. Now, let's go ahead and draw our other line, and we're going to draw this line in green, okay? So there we go. And here we go. The t-intercept would be 11 and 1/4. And the c-intercept is 10, right here, okay? So here we go. Okay, now let's continue on very quickly in blue here. In blue, t is great. Well, hold on. Actually, students, we need to know where to shade on these. Let's go back up to this first equation here in black. And I apologize, students, for not doing this right away. I'm sorry. Let's go back to this inequality here where the intercepts were here, okay? So here's your black line. Now we have to decide whether we're going to shade above or below that black line. So here's what we're going to do. We're going to test 0, 0, okay? So where the t is, I'm going to put a 0. And where the c is, I'm going to put a 0. And you get 0 is less than 24. That's true. So I want to shade down towards 0, 0. Now let's quickly test 0, 0 on the other inequality. So 8 times 0 plus 9 times 0 less than or equal to 9. That's true. 0 is less than or equal to 9. That's true. So we're going to shade down on the green line, okay? Now, next students in blue here, t is greater than or equal to 0. Well, that's going to be a line going through the t-axis at 0. Right here, there's the line. Okay, there it is. T is greater than 0, so we're going to shade this way. Now, c is greater than 0. I guess we'll use a different color. Maybe yellow or red. We'll use red. So, c is greater than 0, so it's a line going through the c-axis at 0. So this line goes through the c-axis at 0. C is greater than 0, so we're going to shade up. So where would they all agree? Well, we know we got to shade to the right of the blue line. We know we have to shade above the red line. We know we have to stay below the green line. And then once we hit that point right there, then we we got to stay beneath the black line. So there's your area right there. So what you just did, students, is you mapped a picture of all of the different possible combinations of chairs and tables. Any ordered pair that falls in this region here is a possible answer to your to how many chairs and tables you can make. Okay. Now, to be honest with you, if you want to find out the maximum amount, your maximum amount is probably going to land somewhere on these turning points on the outside of the region, more than likely. Okay, but they didn't ask us to worry about that, so we're not. So there we go. There's the picture, and this picture here is going to show all of the different possible combinations of tables and chairs that you can make, and satisfy all of your constraints. Okay, all right, next one, number 77. Okay, a person plans to invest up to $20,000 in two different interest-bearing accounts. Each account is to contain at least $5,000. Okay, so let's stop right there. Two accounts, so we're going to call it account number 1. And account number 2. Okay, so both accounts must have at least $5,000 invested in each account. Okay, all right. Moreover, the amount in one account should be at least twice the amount in the other. Okay, find a system of inequalities to describe the various amounts that can be deposited in each account, and then graph the system. Okay, now let's call account number 1 X. Let's call account number 1 Y. Okay, now first of all, think about this. We have no idea how much we're going to invest in account number 1 and 2, but we know this. When we add them all up, it'll have to be less than or equal to what? 20,000. Because that's all you have to invest. Look right here. A person plans to invest up to $20,000 in two different accounts. Okay, so I know when I add up all my money I invest here and all my money I invest here, when I add them up, it has to be less than 20,000 because that's all I have to spend. Now, each account is to contain at least 5,000, so X has to be greater than or equal to 5,000. Okay, and Y has to be greater than or equal to 5,000. Okay, has to be, because it says right here, each account should contain at least $5,000. Okay, so the amount in X has to be greater than or equal to 5,000. The amount in Y has to be greater than or equal to 5,000. Okay, let that sink in for a second. Look that over. Okay, last, students, it says one account should be twice the amount in the other account. Okay, now let's think about that for a second. It really doesn't matter which account you want to have twice as much. Okay, let's just say the X account has twice as much. Alright, so we come over here and we say this X has to be greater than or equal to Y. That makes total sense, guys. Think about it. Whatever amount is invested in account Y, multiply it by 2, and X has to be greater than that because X must have at least twice as much as Y. So you multiply 2 times Y, and X has to be greater than or equal to 2Y. Let all this sink in. Now, common sense constraints. Well, I mean, we could, guys, if you want to put X is greater than 0, now watch this, and Y is greater than 0, that's fine, but you don't need to. We don't know, because look, we already said right here, X is greater than what number? 5,000, and Y is greater than what number? 5,000. So we know X and Y are already greater than 0 based on these two constraints here. So sometimes you'll need common sense constraints and sometimes you won't. Let's look at it again. Look, we already know that X is greater than 5,000, which means it's already greater than 0, and Y is greater than 5,000, which means Y is greater than 0 already. So we do not need those constraints. So there we go. Not too difficult at all. Okay, so there's my constraints. Now let's go ahead and graph this. And with red, okay? So, if you put a 0 in for y, my x-intercept would be 20,000. Put a 0 in for x, and my y-intercept would be 20,000, alright? Now, here, it's going to be a what? It's going to be a vertical line at 5,000. This is going to be a horizontal line at 5,000. Mr. Earhart, how did you know this is vertical and horizontal? Well, look, guys, think about it. Here's your coordinate plane. Here's your y-axis. Here's your x-axis. We have a line, x is greater than 5,000, so we have to draw a vertical line through the x-axis at 5,000. Okay, same thing here. Y is greater than 5,000, so we have to draw a horizontal line through the y-axis at 5,000. Okay, now lastly, this one here, we're going to have to do a quick table of values. So, I guess we'll put in a 1. You know what? We're dealing with some big numbers up here. 20,000, 5,000, all of that. And you know what, students? That means our tick values on our graph are going to be in thousands or something. So I'm going to use big numbers for this here, okay? I'm going to say, I'm going to put 1,000 in for y. And so I would get out 2,000 for x. I'm going to put 2,000 in for y. And get out 4,000 for x, okay? So there we go. So we are totally ready to draw our coordinate plane and get started. So students, go ahead and draw our coordinate plane here. And I guess we would deal in tick marks of, let's see, we have to go up to 20,000, 5,000. I guess we'll deal in tick marks of 2,000. And here we go. Okay, my first line here in red has 2,000 here, put 2,000 here. Has an x-intercept of 20,000 and 20,000. Alright, so here we go. Okay, moving on to the next line. The next line will be a vertical line, and it will go through the x-axis at 5,000. So about right here looks pretty good. There we go. Slide it over just a hair. And let's go back to the red line up here. Let's real quick test 0, 0 to see what we're going to shade. If you test 0, 0, you get 0 plus 0 is less than 20,000. So which is true. So we're going to shade down. Now on the green line, it's x is greater than 5,000. So on the green line, we're going to shade to the right. Now we're going to call this next line blue. Horizontal asymptote of 5,000. So here we go. Let's see what we have here. 1, 2. Going right through 5,000. And let's see. We would shade, y is greater than 5,000. So we would shade up. Positive. And now students, very quickly, let's graph this last line. We have an ordered pair. We'll do the last line here in black. We have ordered pairs of over 2,000 up 1,000. Over 4,000 up 2,000. So there's the black line right there, okay? Now, the line really looks like it goes through 0, 0, so I can't test 0, 0. So I'm going to test this point here, which is 0, 2,000. So I'm going to test the ordered pair, 0, 2,000, okay? So where x is, I'm going to put 0. And where y is, I'll put 2,000. So 0 is greater than, well, 2 times 2,000 is 4,000. 0 is greater than 4,000, that's false. So I do not want to shade looks like to me, students, your region is right here. There it is. Okay? So in that small triangle are all of the ordered pairs that satisfy those constraints, okay? So it kind of gives you a picture, does it not, of how much money to possibly invest in each one. I would probably pick this point right here. And that would be my value that I would invest. Looks like X, looks like it's about at where 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So I would invest 12,000 in the one market, which would leave how much? 8,000 in the other market. That's about right. 2, 4, 6, 8. Perfect. So, but anyways, you do not have to do all of that. But this is the area here in which all of your ordered pairs exist that satisfy the system. Okay. All right. Number 79. A warehouse supervisor is told to ship at least 50 packages of gravel, and that way 55 pounds each. So gravel. At least 50. They weigh 55 pounds each. And for stone, at least 40 bags. And they weigh 70 pounds each. A maximum weight capacity in the truck is 7,500 pounds. Find a system of inequality describing the number of bags of stone and gravel that he can send and graph the system. Okay, here we go. Gravel, let's see. We're going to call X my bags of gravel and Y my bags of stone, okay? So I know for sure I want X is greater than or equal to 50 because I want at least 50 bags. Y is greater than or equal to 40 because I want at least 40 bags. Now, this the pounds here, it looks like each X would get multiplied by 55 because each bag weighs 55 pounds, and each Y would get multiplied by 70 because each Y bag weighs 70, and all of this weight right here had better be, when you add up all of this weight, it had better be less than or equal to 7,500 pounds because that's all that the truck can handle. Now, we did a great job. We got all the constraints up here. We're doing good. However, don't forget your common sense constraints. So normally you'd want to say X is greater than 0. Y is greater than or equal to 0. However, don't do that, okay? Because you don't need to. We already know X is greater than 50, so it's definitely greater than 0. And Y is greater than 40, so it's definitely greater than 0. So you don't need those at all, okay? So here's your constraints. And let's go ahead and graph these now. And first of all, I'm going to reduce this equation here. 5 goes into all of these. So 11x plus 14y is less than or equal to, let's see, 1,500. So I divided all of those by 5. And that makes it a little easier to graph, okay? So we'll slide this up here. Okay, students, now let's go ahead and talk about this first inequality here. We know it's going to be a vertical line at 50, okay? And we know this line here will be a horizontal line passing through the y-axis at 40. Now, for this last line, we're going to put 0 in for y and get the x-axis. They'll get the x-intercept and then put 0 in for x and get the y-intercept, okay? So here we go. We'll do this one in blue. The x-intercept would be, put a 0 in for y, 1,500 divided by 11, 136.4. And then the y-intercept would be 1,500 divided by 14. And that would give you 107.1. So students, it looks like we're dealing with some pretty big numbers. 136, 107, 50, 40. Probably we should go in increments of 10, I would think, would be a good safe number. So so let's go ahead and start with our red line first here. And our red line is going to be a vertical line through 50, 10, 20, 30, 40, 50. So right here. And it says x is greater than 50, so we're going to shade to the right. Okay, now let's go ahead and graph this next line for a horizontal line at 40, so 10, 20, 30, 40. And we notice that it says y is greater than 40, so we're going to shade upward going toward greater than. Now, this next line here, x-intercept of 136, so 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 20, 30, about right in the middle right here. And then a y-intercept of 107, so 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 107, about right there. Alright, so there we go. That looks pretty good, students. Now, let's go ahead and test 0, 0 to see if we get a true or false statement. So 0 for x, 0 for y. That's 0 is less than 1500. That's true. So we shade down for the blue line. So the green line is saying this way, the red line is saying this way, and the blue line is saying this way. Okay. So the area would be this triangle right here. All of the ordered pairs that lie in this shaded area would be values or ordered pairs that satisfy this inequality system up here. Okay? Alright, last one. Here we go. An indoor running track is to be constructed with a space for bodybuilding equipment inside the track. The track must be at least 125 meters long, and the bodybuilding space must have an area of at least 50 square meters. Find a system of inequalities describing the requirements of the facility. Okay? I'm not so sure we'll graph this one. I think we'll just kind of let this one go and just do the equations only. Okay? So here we go. First of all, we understand that we need 500 square meters for the bodybuilding space in here. Okay? Got it? Now square meters means area. Now think about that. They got it written down right here. How long is this line from here to here? X. How long is this line from here to here? Y. So what's the area of this bodybuilding center? Well, you know how to find the area of a rectangle. It's length times width. So x times y would give you the area. Now the area must be at least 500 square meters. So x times y must be greater than or equal to what? 5,000. Because x times y is the area of the bodybuilding place. Okay? So x times y is greater than 5,000. Now, moving on. Next, they tell us that the track must be at least 125 meters long. Now, we know the track is from here to here. X. Okay, we know that. Now, we want the track to run a total. When it says it must be at least 125 meters long, we're talking about around the track, okay? Around the track, it must be 125 meters. So, here we go. Think about this for a second, students, okay? Now watch this, please. I know that from here to here is x long, and because I have a rectangle, I know from here to here is going to be x long also. I know that. Okay? So far I've got part of the track figured out. I know from here to here is x, and from here to here is x. Now the only thing left for me to figure is this distance right here. Because when it says the track must be 150 meters long, it's not talking about going straight across how long it is. Talk about the distance around the track when you run one lap. It should be 125 meters. So, with that in mind, watch this carefully, please. We know the distance from here to here is y. Now, this is called a semicircle. Got it? Semicircle. Now think about it. If from here to here is y, then half of that would be y over 2, correct? So the radius from here to here is y over 2. Okay? That should make sense, guys. Look, watch this again. This line, look, if this is truly the center of a semicircle, then that means all of these lines that I draw are equal. They're all the same because this point here is right in the center of my semicircle, okay? So, if the whole distance from here to here is y, okay? Which it is, if I can get this. If the whole distance from here to here is y, then half of that is y over 2, okay? So, the radius is y over 2. Now, I can figure out this circumference from here to here, okay? Think about it for a second, students. I know that in order to find the circumference around a circle, it's 2 pi r, or we'll just say pi d. Pi times the diameter. Now, if this is the radius, what's the whole diameter all the way across the circle? If I were to continue this circle all the way across right here, my diameter is y. So the circumference of this whole circle all the way around is pi times d, or d is y, so pi times y. But hold it, students, please listen to me. We only want half of that. We don't want the whole circumference of the circle. We want half of it from here to here. So, I'm going to take that whole circumference, which is pi times y, I'm going to cut it in half, or in other words, I'm going to multiply it by 1/2. So it'll be a 1/2 right here. So look what I have, students. I know the distance from here to here is 1/2 pi y, okay? And from here to here is x. And from here to here would be what again? Well, it would be 1/2 pi times y. And then we know the distance from here to here is x. So that's 1 lap all the way around. So with that in mind, we're going to have, if we add all of those up, it's going to be 1/2 xy, or 1/2 pi y, excuse me. Plus x plus this distance 1/2 pi y plus x right here. That should be at least 125. I think it said meters. Let me go back and look. Should be at least 125 meters long. So this whole thing here better be at least greater than or equal to 125. Now we have some like terms. So pi y plus pi y ½ plus a half is 1 pi y. And then x plus x would be 2x. So there we go. Now, students, don't forget your common sense constraints, and we need them. X is greater than or equal to 0. Y is greater than or equal to 0. Okay? Alright, now there's our system. I'm not going to graph this. That's enough for this homework assignment. I hope this homework help video has been a help to you. If you have any questions, don't hesitate to call or email.